Okay, we're back. This is, we're still in chapter 7. We are looking at transverse shear and bending in beams. So we're looking at both the shear stress that comes from the bending, the unbalanced force, and then we have MC over I. So we have a cantilever shown. It's supporting the loads shown. The cross-sectional dimensions of the shape are shown. Determine the maximum horizontal shear stress and the maximum compressive bending stress and the maximum tensile bending stress. We are given Y to the top and we are given IZ. So if I want to know the maximum horizontal shear stress, it's going to be VQ over IT. I'm going to need to find my maximum shear, okay? And I'm also going to need to know what my Q is, and I know that my Q, my maximum shear, is usually at the centroid, wherever I'm going to have that maximum shear force. Compressive, okay, that's going to be MC over I, tensile, MC over I. So I'm going to need to find my maximum moments. And when I look at my moment diagram down here, we're going to find we have 2. And so we're going to have quite a bit of work to do with these 2 things because I need to look at my maximum negative moment. Okay, and I need to look at my maximum positive moment. With negative moment, I know that tension at the top, compression bottom, positive moment, compression top, tension bottom. And because this isn't symmetric, we have different values of Y to the top and Y to the bottom. So we are told that Y to the top, I'm just going to go ahead and come over here like this. Y to the top is given as 1.6483, so 1.6483, which means Y to the bottom has to be all of this 6 minus 1.6483. So we now have to the top and to the bottom, which will come in handy as we're finding Q. So traditionally, what you need to do when you're solving problems is we always start with equilibrium, but we've done a lot of shear moment diagrams, so I would have to draw a free body diagram. I would have to find my reactions. I would then draw my shear and moment diagram, and that's already been done for us. So we can see, looking at our shear diagram, that we have negative 3.1, it comes to 0, and 7,700. With shear, we're not as concerned with positives and negatives. We want the magnitude, and we have 7,700, I think that says pounds, okay, which would also be 7.7 kips. As I'm looking at my moment diagram, I can see I have 2 values that could be possible maximums. This is going to be my maximum positive moment, and this is going to be my maximum negative moment. And again, it becomes very important because of the direction that we have compression or tension. So when I have negative moment, tension top, compression bottom. When I have positive moment, compression top, tension bottom. So we'll do a lot of checking, okay? So let's start with the shear stress. Okay, let's start with that shear stress. I know that the shear stress comes from VQ over IT. The shear that I'll be using is 7,700 pounds. Okay, my moment of inertia about the z-axis was given, 32.62691 inches to the fourth. Okay, my thickness, I know that the maximum occurs at the centroid. So I have this thickness and this thickness. So I'm going to have 2 thicknesses, 2 times 0.4 inches. So I have a thickness of 0.8 inches that's resisting that transverse shear going up and down. And then I need to find Q. Well, I can either go up here and break this into rectangles, however I want to break it, and have 2 shapes, or I'm just going to go below because when you're at the centroid, it shouldn't matter whether you're up or down. And I know then that the height of this, okay, this height right here, has to be 6 minus Y to the top. So I have 6, that's my overall height. 6, enter. Y to the top is 1.6483. So that means Y to the bottom is 4.3517. So when I'm looking at Q, okay, when I'm looking at my value of Q, I have 2 areas. Okay, I have this area of a thickness of 0.4 inches times 4 0.3517 inches. Okay, and then I have that moment arm, and that moment arm is going to go to the centroid of the area. So this moment arm is going to be halfway down. So I have 4.3517 divided by 2, and that gives me my moment arm for that area. So now it's just a matter of plugging things in. My maximum shear stress, I have 7,700 pounds times Q. Well, we have 0.4 enter, 4.3517 times 4.3517 enter, 2 divided by for my moment arm times 3.787459 inches cubed divided by that moment of inertia, 32.62691, divided by my thickness, 0.8. So swap 7,700 times, still have the wrong value, 7,700 enter, 3.787459 times, I don't think I did that right, 7,700 enter, 3.787459 times, divided by 32.62691, divided by 0.8, and I get a shear stress of 1117 psi, which would also be 1.12 ksi. So that's my maximum shear stress, and again, it occurs at the centroid. So now I'm going to go through and determine what is my maximum compressive stress, my maximum tension stress. So I'm going to start with, so this was my shear. And now we're going to look at bending. And specifically, let's look at our positive moment, which is 11,400 units pound feet. So I need to remember to multiply by 12 inches per foot so I can get it into pound inches, okay? As I'm looking at that and I recognize that it is going to be bending is MC over I, well, my moment is given, 11,400 pound feet, so 12 inches to get it to 2 inches. My moment of inertia about that bending axis is given as 32.62691 inches to the fourth. C, I'm going to have C to the top, which was given as 1.6483, and I'm going to have C to the bottom. And that value is 4.3517. Again, if we add these, we get 6 inches. As I'm looking at my positive moment, when I'm going to the top, this is going to get me to my compressive fiber. As I go to the bottom, I'm going to get to my tension fiber. So my stress for compression is 11400 times 12. That's my moment. And I'm going to the top, 1.6483 inches up, divided by moment of inertia, 32.62691 equals. As I'm going to the tension, that's going to go down. It's the same moment times 12. I'm going down this time, 4.3517, same moment of inertia. So let's get that multiplied out. So I have 11,400, 12 times 1.6483 times 32.62691 divided by, and I get 6,911 psi or 6.91 ksi. For the tension, I'm expecting it to be bigger because of this larger C value, 11,400 enter, 12 times 4.3517 times 32.62691 divided by. And again, I expected it to be bigger, 1, 2, 3, so I get 18.25 ksi. And I don't know that these are my largest because I actually have a bigger bending moment right here, and so I need to do the same thing, but we're going to look at bending. At our negative moment of 13,304, again, that's in pound feet, so we'll need to multiply it by 12 to get it into inches, okay? And as I'm looking at this, I'm going to box that in. So I have my moment now. I know that my stress is my over I, or MC over I. So here, as I'm looking, my C to the top is going to be my tension fiber this time. And that C value to the top is still 1.6483 inches. When I look at C to the bottom, that's where I'm going to find my greatest compression. And to the bottom, it is 4.3517. So let's find our tensile stress. So I have 13,304 times 12. Okay, to the top, 1.6483 divided by I, 11, whoops, I could just make up numbers, I guess, divided by I, which is 32.62691. And when we look at our tensile stress at our negative moment, 13,304, enter, 12 times to get units correctly. Going to the top to find my tension, 1.6483 times, divided by 32.62691 divided by. And I get a stress of 8,065. That's PSI, remember, so it's going to be 8.07 KSI. So let's look at our tensile stress. We have 18 and we have 8.07. So the maximum occurs where I have my positive moment. So I would need to note that this would be my absolute maximum tensile stress. But I need to do the same thing and find my compressive stress. So it's going to be the same moment, 13304, enter 12 times to get it into kip inches. But this time my compression occurs at the bottom, so 4.3517 times divided by 32.62691 divided by, and I get, whew, that's a huge number. Remember, this is in PSI. 1, 2, 3, so I get 21.29 KSI. So if I'm looking at my compressive stress, when I look over here, it is 21.29. When I look in my positive moment, it's only 6.91. So my largest compressive stress actually occurs at my negative moment. So this is where my maximum compressive stress is occurring. My maximum tensile stress happens to be occurring at my positive moment. So my answers are going to be 1.12 KSI for shear, 18.25 KSI for tension for tensile bending stress, and 21.29 KSI for compressive bending stress. If I had to go back and calculate like what load P or W could be on here, I would need to make sure I used this region to compare against an allowable compression, this an allowable tension, and that an allowable shear.